In chapter 8, lesson number 4, multiple representations of functions means we can represent the function by many ways. So let's see this real world link. A group of friends are going to the museum. Each friend must pay an admission price of $9. This table shows the total cost of admission. Number of friends X could be 1, 2, 3, or 4. If it's one friend, for sure, he will pay $9. Two friends will be 2 times 9, which is $18. Three friends, 3 times 9, which is $27. Four friends, 4 times 9 will give you $36. Now we can graph, as you can see. So from 1 up to 9 will be here, before 10 a little. 2 up to 18, before 20 a little, 18. 3 up to 27, after 25 a little, so it could be here. From 4 to 36, from 4 up to 36, this is 35, so 36 will be. Now, problem 1, complete the table and graph the ordered pairs, number of friends to the total cost. Number of friends is X, as you can see, total cost is Y, and every point of those is represented. Now, describe the graph. How can we describe this graph? Let me lift the page up a little. And let's take these points. All of it. Complete the table and graph the ordered pairs. We graphed already and we complete the table. Describe the graph. So we can say that the graph of the function is linear. This is how you can describe. Linear means they appear to be on the same straight line. So the graph of the function is linear. Write an equation to find the cost of n tickets. Of course, this is 9n. We are multiplied by 9, so 9n. List the ordered pairs of the cost when 5 friends go to the museum. 5 friends, so 5 and 45. Means if they are 5 friends, they should pay $45. Now, represent functions using words and equations. A runner's distance in a marathon is equal to 8 miles per hour. A runner's distance means if you want to find the distance is in a marathon is equal to 8 miles per hour times the number of hours. So the equation in this case, this is the word. If you want to write it as equation, so distance equals 8 times t, such that t is the number of hours. So sometimes we give you word phrase like this one, and you need to write down the equation. Words and equations can be used to describe functions. For example, when a rate is expressed in words, it can be written as an equation with variables. When you write an equation, determine what variable to use to represent different quantities. Like in this example number 1, the drama club is holding a big sale. They are charging $5 for each pie they sell. For each pie they sell, $5. Write an equation to find the total amount earned T after selling P pies. So it will be like this. T equals 5 times P. We don't want you to write all this stuff. We just want you to write this equation. T equals 5P. Another example. In a science report, Mia finds that the average adult breathes, breathes 14 times, breathes 14 times each minute. The average adult breathes 14 times each minute when not active. Write an equation to find the total breath B in an active person take in m minutes. So very clear, B equals 14m. Now let's try to do this. We will give you phrase, we will give you verbal phrase, and then we are going to ask you to write it as an equation. A mouse can travel 8 miles per hour. 8 miles per hour. Write an equation to find the total distance d. A mouse can travel in h hours. So we are going to say d equals 8h. Distance equals 8 multiplied by number of hours. So the same in words, but we write it in symbols. Problem B, Samantha can make 36 cookies each hour. Write an equation to find the total number of cookies C that you can make in each hour. Very easy. So C equals 36 H. So the number of cookies equals 36 times the number of hours. See how easy? Represent function using table and graph. Of course, if we have a table, we can plot the points, then we join the line to make the graph. Like in this example, example number 3, the student council is holding a car wash to raise money. They are charging $7 for each car. $7 for each car. So if it's one car, 1 times 7 will give you 7. 2 cars, 2 by 7 will give you 14. 3 cars, 3 by 7 gives you 21. 4 cars, 4 by 7 will give you 28. So we have input, output, means we have ordered pairs now, and these ordered pairs will form the table. See how easy? Another example, if we want to graph this one, we said 1 and 7, 2 and 14, 3 and 21, 4 and 28. So, of course, if they didn't, no car means no money. So 0 and 0, 1 and 7, 2 and 14, 3 and 21, 4 and 28, and they appear to be on the same line. And of course, here the amount is increasing by 7. As long as we are increasing one car, the amount is increasing by $7. Let's take this example. While in normal flight, a bald eagle flies at an average speed of 30 miles per hour. Write an equation and make a function table to show the relationship between the total distance d that the bald eagle can travel in each hour. So first, let's write an equation that the distance equals 30h, means 30 miles per hour. So 30 miles times the number of hours. Now, if the number of hours is 1, so this will be 30. If number of hours is 2, so here 30 times 2 will give you 6. Number of hours is 3, so 30 by 3 will give you 9. Now, if the ball, if it didn't travel 0, so it would be 0. 1 up to 30, 2 up to 6, 3 to 9. Then we can join with a line. And we can make an arrow. Means as long as number of hours increasing, the distance also will increase. Means if we take 4, it will be 120. If we take 5, it will be 150, and so on. Graph the ordered pair of the function, analyze the graph. Analyze, so are going to say the function is linear. This is how we describe is linear. Every hour, distance increases by 30 miles. The function is linear. This is the first description. Second description, every hour, distance increases by 30 miles. Now, in the guided practice, it's only one problem, and we will solve it together. The school cafeteria sells lunch passes that allow a student to purchase any number of lunch in advance for $3 per lunch. $3 per lunch. Write an equation to find T, the total cost in dollars for a lunch pass within lunches. So T equals 3N, since 3 per lunch and N is the number of lunches, so 3 times N. B, make a function table to show the relationship between the number of lunches in and the cost. Okay, if this is 1, 3 times 1 is 3. If 2 will give you 6. If 3 give you 9. If 0, let's say if you have 0, it will give you 0 as well. So 0 and 0, 1 up to 3, 2 up to 6, 3 up to 9. See how easy? Now you can join with a line to show that it is linear function. And you describe and you say it is linear function. So graph the order pair, analyze. Analyze means first you say the function is linear. Second, you say every lunch increases, the cost is increases by 3, as you can see. from the graph and also from the table. So total cost, total cost is increasing by $3 per lunch. See how easy? That's it for our lesson for today. And if you have a question, you can write it down in comment.